Hello friends, this is Durga again from Technology Mentor / ITversity, and as part of developing MapReduce applications using Hadoop APIs, we started from simple MapReduce application which uses default MapRen reducer. Then we have developed two or three MapReduce applications using almost all features like combiners and how we can do the filtering effectively, partitioners, and all those things to connect all the dots so far, and also to connect all the dots covered so far, including comparators to grouping and sorting the data, to compute to implement complex algorithms like ranking. We are implementing a MapReduce application called top 3 stocks by volume. For that, we created this package and we developed a driver, mapper, reducer, and we are able to see the output as expected in the HDFS. So we can see four files in ascending order by date, and we can see the stocks, top 3 stocks for each date. Let me show you. Let me show you the output. So this is the directory which is generated using that. This is the directory which is created as part of the final run of our previous job. And you can see that we have consolidated all the files, and then you can actually cat on that, and you can see that in ascending order data is displayed with the top 3 stocks on each and every day by volume. Okay, the last field after last comma is volume for a given stock, and this is the date, and this is the final day in 2013. And Bank of America, I'm not sure what HTZ is, and GE are the top 3 stocks. So one thing we have done in this program is that we actually hard coded our partitioner here. We are hard coded in such a way that data from 2012 January to 2000 December 31 is distributed into 4 partitions. Now if we change the number of reducers to increase the processing power for our algorithm, for our application, even then it only writes into 4 reducers. Means most of only 4 reducers will be doing all the work, and 2 reducers will not be used at all if you use 6 reducers. For that reason, this is not a very reliable logic. Instead, you have to come up with more logic where if the parameters are changed dynamically, it should not impact the outcome of our MapReduce application. For that reason, this is not completely reliable, and if we remove this, then data will not be sorted. You can so for example, let's say I am going to driver, and instead of implementing this not so very good logic, let's take the first column itself, and which is our date, and then you can say part value mod num partitions. So this will address the issue of dynamically changing number of reducers, but the side effect of this is data will be skewed. You will not be able to get the global sorting. Let me run this program so that you understand what I'm talking about. And here instead of 4, I'm using 6. If with the previous logic, if I use 6, only 4 reducers will do the job, and data will be sorted by the file name, but 2 of the reducers will not do any work. Now we removed that logic, and we are actually using mod function on the value itself, which is the long data type. And now data will be distributed evenly across all the 6 reducers, but you will be compromising the global sorting. Let me do this, run as run configurations, and I'm writing to output directory 00, click on run. So now our MapReduce application ran successfully with 6 reducers. I'm coming out of this cluster and going to this directory, and you can see 6 files evenly distributed. But if you do cat on this and if you look at the data, you can see that data is all scattered. So first you got 6th January, 2nd, 12th January, 3rd, and then 18th January, 24th January, etc. So it's not in proper order, but data is distributed across all the 6 reducers. So how can we address this in more reliable fashion? One of the ways is to implement something called total ordering partitioner, but that is not the only option we have. And there are other ways also to do that, and one of the way to achieve that is by using multiple outputs. So what is multiple output? So far, to set the output path, we are using file output format, and the program runs whatever path that is specified as the output path. In this case, if you go to the arguments, you will get the output path. This is the output path, the last parameter of the 3, and then you can go to that location, and you can see that data is so there is a format in the file name. The file names are prefixed with part minus r, and then all zeros, 1, 2, 3, 4, 5. Okay. And using our range simulator earlier, what we have done is we made sure that the first 6 months data goes to 0, 0, 0, 0, then the second 6 months to 1, third 6 months to 2, and fourth 6 months to 3. And then we can actually cat this data and write into different file, and we can get the total ordering on the data set. Okay, so if we make sure that data is stored in files in such a way that file names are in ascending order and the data also matches the order of the file names, then we can achieve the total means global sorting of our data, even while using more than one reducer while running the MapReduce application. So how can we achieve that? Instead of just using the default way of creating the files, if we can tweak in such a way that it can write to different output paths using appropriate names with some business logic included in the naming convention, then we can easily get that. So where to implement that multiple outputs? Either you can do it in mapper or reducer. If you are running map only jobs where you will not be invoking any reducer, even there you can actually define the multiple outputs, and the data will be written to files which have some business logic embedded in that. So what are the steps to implement multiple output format? You need to have a class level private variable or public variable, it doesn't matter, with type multiple outputs. Okay, make sure you choose any class from MapReduce API, the new API. You should not go to the MapRed API, which is old API. You will see many surprises and inconsistent results. For that reason, use only the new API if you are developing the application with new API. And here it takes key and value as part of the class specification. And in our case, we are writing, this is while writing output to the HDFS. So we need to give output key and output value types, which is null, writable, and text. Okay. And then we can say multiple outputs. Okay, now we have seen setup method as part of the filtering application. Means when we actually made the changes to our average stock volume per month to introduce filtering. We have seen setup method, which is used to read the configuration data and build the hash map out of it. Hash set out of it like this. So we got the stock tickers in comma separated using a parameter, and we by using -d while invoking the program, and then as part of setup method we implemented this logic where we can actually build our hash set. So similar to that, we need to have setup method even for multiple outputs. And if you want to get the syntax, you can go to Firefox or any browser and then go to grep code and then search for org.apache.hadoop.mapreduce reducer. Hit enter. Go to the source code of this file. So if you want to copy the template, so you have the setup method here and you have the cleanup method here. We can actually copy this, but if you copy it directly like this, you will get these numbers also. To avoid that, you can actually click on raw. So you will see the code in raw format, and you can copy this and paste it. And also we need cleanup, because when it comes to file systems, you need to close the file system. So you need to have the cleanup method. And let me put it on the after the reducer. And if you recollect, this setup method will be invoked before the task is started, and cleanup method will be invoked after the task is started. So if you have 6 reducers, for each reducer task, you will this setup method will be running once at the beginning of the task, and cleanup will be executed once after beginning the task. And it will happen for each reduce task we are trying to use to process the data. That being said, let me format this and delete this line, nothing. Okay, and then you need to build the multiple output object. So multiple outputs equal to new multiple outputs, and you need to pass the context to it. So context is the one which is passed to our setup, so we can use that, and we need to specify this here, and also you can close it here. Okay, and when it comes to writing to the files, if you see our means as of now, if you go through our partitioner logic, it is picking up the date for each and every record, and it is partitioning by date. So at any given point in time, a given date will go to only one partitioner, which means eventually to one reducer. And then the data for each date is sorted in descending order because of our sorting comparator on the trailing field, which is volume, and then it will be grouped by date, and then reducer function will be invoked for each date. Okay, so what we can do is, here in the reducer, instead of using context to write, which will use the default record writer into our text output format files, now we have to use multiple outputs. Okay, and then it takes 3 parameters. First one is the key, second one is the value which we want to write, so there is no change in that, and the third one is the a string which can use to pass the to customize our file name. In this case, let us prefix with the date itself. Okay, for that what I'm doing is from input key we need to get the first, and it is of type primitive long, and we need to build a long object so that we can apply toString. and then I need to apply toString function on this because it requires string type to pass to the file name. That being said, we are done with the code changes right now. We have implemented the setup method, cleanup method. Cleanup method is to close the multiple outputs object, and the setup method is to initialize our multiple outputs object with appropriate key and value types and the context. And now we can actually run this application. Click on run configurations, and I am using 01 as the output directory. Apply, run. Okay, now it will take a couple of minutes to run, and then we will review the. So it is executed successfully. Now I am going into the directory, and you can see that a file is created for each day. So there are too many small files in this case, but still okay, means we can actually work around this, and we will see that in a moment. So first let me do this. So I am copying all the files into part consolidated to validate that our data will be sorted, and then you can actually do part consolidated, and you can see that data is sorted from 2nd January 2012, 3rd January 2012, 4th January 2012, 6th January 2012, 9th January 2012, so on up to 31st December 2013. So using multiple outputs, you can actually get the global sorting, and if you see now, if you want to increase the number of reducers, you can increase up to whatever number you want, up to 522 also if you want to process too much of data using many reducers. And now your sorting is distributed, and it can happen much faster than compared to single threaded. And if you feel that we are running into too many small files, in this case we have seen as part of file system programs how we can actually invoke a method called copy merge by passing the source path, the target path, etc. And also you can actually set true so that it will delete the existing files, and using this you can actually merge all the small files into bigger files, and it will take the names in ascending order. So you can leverage this to get your global sorting implemented, and at the same time if you want to overcome too many small files issue. And also there is other way also which I would like to cover before wrapping up. That is, not only you can actually give the file name to a specific value, you can actually create the directories also. Okay, and also in this case, if you look at the first long pair partitioner, here our key means that the way it is partitioned is based upon date. Instead of date, what you can do is you can so what you can do is, so instead of partitioning by date, if we partition by month, so all the data for a given month will go to one reducer, and then as part of the multiple outputs we can actually prefix the file name with the month itself. Let's see how we can do that. So here we are getting the date, and the date is in a particular form YYYMMDD, and let's get the first 6 digits from this, and then apply the mod function on that. So for that, what you need to do is you have to create the new long object dot get string, sorry, toString. Now we have toString object, and we can do substring from 0 to 6. So first 6 characters we are getting, and then we need to apply new long here again, and then we can get it in the long form. Long value. Now it is again long value, but we are only using first 6 characters, which is year and month, 201 201 for January 2012, etc. So using that change, so making that change, and also in reducer we have to implement similar logic. So our key will still be date, but the way it is date and volume, but the way we are partitioning is only by the year and month. We are not including the date portion to it. So what we have to do is here, as we will get date as part of the get first, we have to apply substring and 0 6. Okay, now the file names will have prefix of month only, and all the data related to a month will go to one file. Now let's run this and validate. Run as, run configurations, click on run. So let me change the directory name to output 02 and click on run. So it is done. Now let us read this and go to the directory ls-ltr, and you can see that the files are now prefixed with month names, and then you can actually do cat of 201 star part consolidated and hit enter, and you can see the file and the data is in sorted order. And also now the data is in multiple files, but they are sorted by the file names. Okay, and here if you look at these numbers, this behavior is not changed in this. It is still the means that all the data related to 2013-12 is processed by partitioner, which result into 0 as the reminder when the mod function is applied on this year using 6. Similar to that, 7 is 1, 6 is 0, etc. Okay, but you will see these empty files, you can ignore them, and there is a way to eliminate these things while running the MapReduce program as well. But for now, I don't want to get into that. That is not that important. The main important thing is now you have fewer files, and still the data is sorted in proper order using the file names, and also we ran the program using multiple reducers. So before wrapping up, I would like to show one more thing. So you can also implement this kind of logic where we are saying that use this format for our path, and then this you can actually create multiple levels of directories also. So here we are creating only one directory, and the pattern for the directory name, I want it to be like this. Okay, which means the first 6 digits of our key, the first 6 digits of our leading field of our key, which is date. So it will be YYYMM format. So year and month will be used to create the directory, and if you want, you can say trade month equal to also, so that it will actually prefix a particular string before appending the day, year and month to that. And then after building the string with the path, you can pass it as a parameter instead of passing string directly. Now we are actually using the path created a string separately, and then we are passing the string object, which is formatted using the path, to the multiple outputs dot write. So now let us run this, run as, run configurations, and now it is 3 here. Click on run, and it will take a while, and then we will review. So it is executed. Now I'm looking at the output. I'm going back to the directory and see output 03 ls-ltr. You can see that there are multiple directories created for each month, and you can go to each of these directories. Trade month equal to 201201, which is month January for 2012, and you can see the data, and you can see part -r -003, and you can see all the data related to January in ascending order. So it's a combination of partitioner, sorting comparator, grouping comparator, and multiple output formats, which we are using to get our top 3 stocks for all our New York Stock Exchange data in proper order using multiple reducers. So that's what we have achieved by writing this little bit complicated MapReduce application to address much complex use case to get top 3 stocks by volume on each and every day that is part of our data, that is using our New York Stock Exchange data. So you can play with it, you can create multiple directories also. So this helps you a lot while designing your MapReduce applications to make sure that data is distributed in a proper format while writing into HDFS after processing data using MapReduce applications. So from database terms, it will help you to do partition pruning or directory pruning, where now you can actually write file system APIs to do the pattern matching using this information to implement the downstream MapReduce application on top of this data. Okay. So that being said, I will wrap up here. We have seen quite a few things here. We have seen how we can replace a primitive range partitioning algorithm that is implemented in the partitioner with multiple output formats to get the global sorting even when we change the number of reducers dynamically. In this case, the data will be partitioned, the data will be processed and output in much more even fashion, and data will be distributed evenly between multiple files, and also data can be sorted globally using as many reducers as we want while we try to run our MapReduce application. That being said, that's it for now, and in the next few videos I will be covering another very important concept called counters, and then we will write our final MapReduce application which covers the joining the data sets. The reason why I want to cover counters before join is as part of demonstrating the MapReduce applications using joins. I want to cover everything that is important as part of the MapReduce application development, including counters. For that reason, I would like to cover counters. Probably I might write counters on top of this program itself to explain what counters are, and then we will write the algorithms for join. That being said, I hope you are enjoying the content so far on my channel. If you have any feedback or if you want to ask any technical question related to a particular video, please leverage the comment section of the video. And if you have not subscribed to my channel yet, please do so. You will see a lot more content than just Hadoop or big data, and the quality will definitely improve over time. Thank you. Bye.